Hello, my name is Bobby Kasthuri. I'm a neuroscientist at Argonne National Labs and an assistant professor in the neurobiology department at the University of Chicago. And the thing I'm interested in, that my lab is interested in, is we want to be the first people in the world to map a human brain at the level of how every brain cell or neuron connects to every other neuron in the brain. What are the payoffs? Why do we want to do brain mapping? And we think the payoffs are enormous. I think for the first time we're going to figure out what the physical basis of mental illness is and then solve it in a rational way, in a top-down way where we understand the disease and try to cure the disease as opposed to always just trying to cure the symptoms. And when we have a deep understanding of how the brain works, we might be able to reverse engineer the things that brains do into our own robots and algorithms, like creativity, like humor. These are things we believe that must have a physical substrate in the brain, and once we understand that physical substrate, we can reverse engineer it into our own future with artificial intelligence and robots. In 10 years, in 15 years, maybe 25 years, the huge part of our energy budget, what we spend energy on, is no longer going to be the gas we put in our cars or the oil that we put in our airplanes. It's going to be moving information up and down from the cloud back and forth. This is going to be the largest consumption of all of our energy. If we can understand how the brain moves information and processes information for 20 watts of energy, I believe we can make a significant impact on the future energy crises. The only way that we could ever succeed in that is to get collaborators and friends who really have huge computers, which is actually one of the reasons that I'm at Argonne, because currently they have one of the top 10 best, smartest, best looking computers in the world, and that's just going to keep advancing. So at some level, brain mapping, the way we want to do it, can only be done here at the University of Chicago and Argonne National Labs because of the resources that we have there.